Morning students. Today we'll see the silt pressure. We know that the suspended particles moves through the water and reaches to the reservoir of the gravity dam. It settles down due to the effect of its own weight. Here we'll draw the cross section of the gravity dam, and here near the face of the dam the suspended particle settles. Let the height of this suspended particles is small hs, and the pressure variation will be like this. The pressure variation, or we can say the pressure due to the suspended particles, is same as that of the earth pressure. In this case, the earth pressure will be in the case of active. So we had already seen the earth pressure due to active state is PA is equal to KA into gamma into Z. Z is what? The height of the suspended particles or soil, and gamma is what? The unit weight of soil, and K is what? The active earth pressure coefficient. So if we want to write the silt pressure, the notation will be little different. PA is equal to KA gamma S. Here gamma S is submerged unit weight because the suspended particles is submerged in the water, and height of the silt particles is how much? HS. So here K is what? The active earth pressure coefficient, whose value is 1 minus sine phi upon 1 plus sine phi. This may be written as tan square 45 minus phi by 2, and phi is what? Angle of internal friction, which we had already seen in the soil mechanics or geotech paper. Or angle of repose. Gamma is what? Submerged unit weight. Of silt. This can be written as gamma saturated minus gamma water, and HS is what? The height of the silt load or silt suspended particles, or the soil which is settled at the base or near the face of the dam. So here the pressure variation will be how much? Ka gamma S into HS. This value. So the force due to silt Fs. So the force due to silt, that is Fs, will be half into Ka gamma S into Hs into Hs, the area of this pressure diagram. So this can be written as Fs is equal to half into Ka into gamma S into Hs square. So here we can see that the force due to silt load will be Fs is equal to half into Ka into gamma S into Hs square. And here we can see that silt is in the inclined with the face of the dam, so it will act in the vertical direction. So it will act in the, due to its weight, it will act in the downward direction. Also, one more formula is given by USBR. In the absence of any data, the Fs can be taken as 360 Hs square. Hs is what? The height of the silt upon 2. This formula can be taken in the absence of the data, in the absence of data related with the earth pressure. So this formula can be used. This is given by USBR. This is in kgf. Now let us move ahead towards the wave pressure. The fifth one is wave pressure. This wave pressure is generated due to the wind. Whenever wind flows to the free surface of the water, returning back in the reservoir, or water retained behind the gravity dam, then wave pressure is generated. Now let us try to understand through the sketch. This is the cross section of the dam. And this total height is height of the wave. This can be written as HW. This is FRL, full reservoir level, and this height is this height is 2 by 3 SW 2 by 3 into SW, and this height is SW upon 3. This is water, and this Due to the wave pressure, the pressure variation will be like this, triangular. The pressure variation is triangular. This is FRL. This is the maximum pressure, PW. And the height of the maximum pressure from the FRL is SW by 8, and the maximum force from the height of the maximum force from the FRL, or we can say the resultant force. Suppose this resultant force is FW, and this height is 3/8 into SW, and this total height is 5/3 HW. Here PW, this PW is 2.4 into gamma W into HW. This is acting at SW by 8 above FRL. So FW is what? Force of wave action on the dam body. So force due to the wave action per unit width will be this area of loading diagram. This is loading diagram. So here we can write FW is equal to half into PW into 5/3 SW into 1. So the value of PW is written over here. This is 2.4 gamma W SW into 5/3 SW. On solving this, FW is equal to 2 into gamma W into SW square, and it acts at 3/8 into HW height from the FRL. FRL was full reservoir level. Here SW is what? Height of the wave, and it depends upon the V and F. V is what? The velocity of wind, and F is what? The length of fetch. Height of wave and is dependent upon v is what? Wind velocity. And f is what? Fetch, length of fetch. And as per Indian standard, the SW is given as 0.32 root under V into F. This will come in meter when length of phase is greater than 32 kilometer, and when F is less than 32 kilometer, then formula is SW is equal to 0.32 root under V into F. V is velocity of wind and F is length of the fetch, plus 763 minus 271 into F raised to power 3 upon 4. So here, for the calculation of the height of the wave, as per Indian standard, the formula is 0.32 root under V into F when F is greater than 32 kilometers, and when F is less than 32 kilometer, then formula is 0.32 root under V into F plus 0.763 minus 0.271 F raised to power 3 upon 4. And phase is what? This wavelength. Suppose this is the waves and this length is called fetch, and fetch is in the kilometers.